Okay, so welcome to probability, the last section of Module 6 and the last piece of the Module 6 worksheet pack. So when we're talking about probability, we can say that all probabilities between 0 and 1, where 0 really represents, that's not my pen, 0%, and 100 probability of 1 represents 100%. So probability of 0 means the event is impossible. So the example they give is getting an A in this class if you don't need homework. The probability of 1 means it's certainly going to happen. So of you having a birthday, I guess if you died, you wouldn't have a birthday this year, but you would definitely still have a birthday. So the way that we calculate probabilities is like this, and this is the way I think about it. I think about favorable outcomes over total. So the total way things can happen is going to be the denominator piece. The ones that we're looking at for those, the favorable ways, are what's in the numerator. We can express probability as a fraction, we can express probability as a decimal, we can express probability as a percent. So I'll kind of show you these things, and we'll do it contextually. So let's just jump into these problems here. Now, it says a glass jar contains 6 red, 5 green, 8 blue, and 3 marbles. If a single marble is chosen at random from the jar, what's the probability of choosing a red, a green, a blue, or a yellow marble? Now, when I said that the total possible outcomes, we're talking about the total number of marbles here, because we have this. So 5 plus 6 plus, that's 11, plus 8 is 19, plus 3 is 22. That's why you're seeing this denominator of 22 here, 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 and here. Now, the number of ways to choose a red is totally dictated by the number of red. Now, there's 6 red marbles, so the chances of getting a red marble when you pull it out of this jar with these 22 marbles is 6 out of 22, or 3/11. Now, we could go on to divide 3 by 11, and if we do that, you're probably going to want a calculator. You get approximately 0.27, which would say there's a 27% chance. So we can express probability as a fraction, we can express it as a decimal, or we can express it as a percent. Now, ways to choose a green marble. How many green marbles are there? There's 5. So 5 out of 22, once again, we could divide that out and get roughly 0.227, so about 22.7% chance of getting a green marble. Same thing with a blue. How many blues are there? 8. So favorable outcomes, when we're trying to get a blue marble, there's 8 different marbles that we could choose from. So we get this, simplifying this really quickly, gives us 4 out of 11, which once again we could divide 4 by 11, get 0.36, or about 36%. And then finally, ways to choose a yellow marble. There are 3 yellow marbles. There's 3 out of 22. Additionally, we could go back to that as well. We could divide our 3 by 22, get 0.136, so about 13.6%. And I'm not totally concerned with where you're rounding these things. I rounded the 10th here. I rounded to the whole percent on this, and the first one rounded to the 10th there. Just because the 0.27 was 0.272, that's, just roundable. So I'm not totally hung up on that. And the instructions will give us an idea as to what we're doing. So here, we want to find out the theoretical probability of each, and we'll just find it as a reduced fraction at this point in time. We could turn it into a percent if we wanted with our calculators by first turning it into a decimal and then the percent. So what is the probability of drawing a king from a 52 card deck of cards? Now, the question is how many kings? Well, there's 4 suits: spades, clubs, diamonds, and hearts. So that means there's a king of each of those. So we have 4 52nds, which we could reduce that into 1/13. So 1 out of 13 chances of getting a king from a standard 52 deck of cards. So rolling, and this is a 6-sided die, one of those, dies that look like a cube. Rolling a die and getting a 3 or a 4. Well, on one of these cube-looking die, there are 6 sides. You get a 1, 2, 3, 4, 5, or 6. A 3 or a 4 represents 2 of those possibilities. So we have 2/6, which we could reduce to 1/3. And once again, we could turn this into the decimal, 0.33, or say there's a 33% chance, but we're just going to stick to fractions right now. Now, the chance that you're a male or female. Well, if we think how many genders there are, and we're just assuming there's two genders, there's two different genders we could choose from. You're either male or you're female, so this has both the chances. So 2 out of 2 gives us 1, which really translates to 100%. So there's a 100% chance that you're either male or female. Now we talk about drawing a black jack from a standard deck of cards. There's 2 suits that are red and 2 suits that are black. So there's the jack of clubs and the jack of spades. Now a standard deck has 52 cards, so this would be 2. The favorable outcomes, the black jack, the jack of spades and jack of clubs, over the total number of cards, 52, which we could reduce to 1/26. And that doesn't really look like a 6, but now it does. Now, 5 is, what's the probability of guessing correct on a multiple guess test with choices A through D? We're assuming there's only one correct answer, so there's one favorable outcome. And if we count up A through D, A, B, C, D, there's 4 choices. So 1/4, which you could turn into the decimal 0.25, which you could say there's a 25% chance of just guessing the right answer on that. Now, what is the probability of not being dealt a jack or an ace from a standard deck of cards? Well, okay, standard deck of cards, there's still 52. Now we want to think about what are the cards that are not jacks or aces. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, queen, and king. So there's 11 different cards, and there's 4 suits, so there's 44 cards that are not a jack or an ace, so we can say 44 out of 52, which we can reduce that to 11/13. So that's what we're looking at right there. Okay. Now, we got a couple more of these, and we can go right here. So your sock drawer is a mess. There's 12 black, 6 red that are all mixed together. So 12 black, 6 red. What are the chances, without looking, you pick out a red sock? So, how many total socks are there? Our 12 plus 6 looks like about 18. How many red socks do we have? 6 out of 18, which we're going to reduce to 1/3. So there's a 1/3 chance of picking a red sock. Now, what are the chances of picking a black sock? Well, if you don't pick a red sock, you're going to have to pick a black sock. If there's a 1/3 chance of picking a red sock, there's a 2/3 chance of picking a black sock. Okay. So, here, we're visiting a kennel that has 3 German Shepherds, 4 Labrador Retrievers, 2 Chihuahuas, 3 Poodles, and 5 Westies. When you arrive, the dogs are taking a walk. What's the probability of seeing a German Shepherd first? Well, once again, we want to think, what total number of German Shepherds, the favorable outcomes of seeing those, over the total number of dogs. Since there are 3 German Shepherds, it's 3 over, what's the denominator here going to be? Well, how many total dogs do we have? We have our 3 German Shepherds, plus 4 Labradors, that's 7, plus 2 Chihuahuas, that's 9, plus 3 Poodles, that's 12, and then 5 Westies, 17, so 3/17. And we'll just leave it as that, but of course we could divide 3 by 17, and that's going to get us about 0.176, which is a 17.6% chance that we are going to first see a German Shepherd. So, the next couple involve a little bit more, so let's get down here really quickly. So now, it says the class of 2012 is doing a fundraiser. A field is divided into 24 equal sections, which you can see here. Yours has the grid around it, but that's essentially the sections right there. There's 1, 2, 3, 4, 5, 6, by 1, 2, 3, 4. So we have 6 columns and 4 rows. Now, they let a cow loose onto this field, and it drops its pie. I think we all know what that means. Onto this. Now, the person that purchasing the section where the pie is dropped wins a big prize. Now, the sections are labeled with the person's name. What are the chances the cow drops its pie in Amber's section? Well, how many total sections are there? We have 24. It says that right there, but we can see we have a 4 by 6 grid, so there's 24. Okay. Now, how many of those have amber? Looks like we have 1, 2, 3. So 3/24, which you're going to reduce the 1/8. So there's a 1/8 chance that amber wins. Now, what are the chances that Condell or Scotty wins? Still, there's 24 sections. So let's count up Condell or Scotty. Condell's 1, 2. Scotty 3, 4. So Condell or Scotty is 4/26 or 4/24, which you can reduce to 1/6. Okay, and then now we want to find out what the probability is as a percent that Donna doesn't win. So one way we could do this is find out the probability that Donna does win. So we have 24 choices still. How many Donnas do we have? It looks like we have 1, 2, 3, 4. 4/24, which reduces to 1/6. Now, we could divide this. 1 divided by 6 is going to be about 16%. Now, if there's a 16% chance that Donna does win, we could subtract that 16 from 100 to get the percentage chance that she doesn't win, which is going to be about an 84% chance. And this follows that same logic as if I said, there's a 40% chance of rain tomorrow. What's the chance that it doesn't rain? Well, it's going to be the complement. So if there's a 40% chance it does rain, there's a 60% chance that it doesn't rain. So we're following that type of thing here. So the last problem, it looks like we're missing some pieces there. Well, we'll just run with this as it is. I'll draw a little piece on here. It is about a spinner wheel. Now, I'll just draw that on there. I drew it on there one time, but it looks like we're missing it again. Now, red has a 90-degree angle. Green has a 120-degree angle. And then blue is the rest of this. Now, how many total degrees are in one circle? Well, there's 360. So, for the first one, we're thinking something over 360. The second one, we're thinking something over 360. The third one, we're thinking something over 360. And the fourth one, something over 360. And we'll find these as a percentage afterwards. So, percentage of landing on red. Well, this is 90 degrees out of 360. 90 over 360, plug that in your calculator, is 0.25. So there's a 25% chance of this landing on red. Now green, we have 120 degrees of green. So that's a favorable outcome. 120 over 360 is 0.33. If you plug that in your calculator, which is 33% chance. Now, blue, of landing on green or blue, green is 120, blue is the rest of this. The thing that we know is there's 360 total degrees, 90 of them are red, so to find out green and blue, subtract 90 off of this. When we do that, we get 270 degrees. So if it lands on blue or green, that's 270 degrees over 360, which is 0.75 or 75%. And then the probability of it landing on yellow, well, there is no yellow. So 0 over 360, and that gives us a 0% chance of the spinner landing on yellow. So hopefully that made sense. I know that most people actually do understand probability, but if you don't, feel free to watch the videos, send me an email and see what's up. Hope you enjoyed Module 6. I'm going to get content up for Module 7 here sooner than later. So yeah, keep studying and do your homework and ask questions.